First, we're going to look at a situation that's going to arise when we do systems with circles. And basically, you'll see here I have x minus 2 squared, which looks kind of like a circle equation, and then I have something in parentheses minus 8 squared. So if we look back at where this is going to come from, basically this second section is y minus 8, and then we plug something in for y. So the first thing I'm going to do here is simplify this expression. So we have parentheses, but in here it's just addition and subtraction. So I can simplify this. Positive 3 minus 8 is negative 5. So I am going to rewrite this side, which I would usually do in the same step as something else. But basically that simplifies, and the original part, I'm just going to rewrite. Now, because I have these binomials squared, I know I need to write it twice. So I have x minus 2 times x minus 2 plus negative x minus 5 times negative x minus 5. Now, if you haven't already started doing this, this is a really great time to be able to multiply binomials together in one step. So we know we have our first arrow, so we write x squared. We're going to do our second and our third arrow together. So we have negative 2x is negative 4x. And then our last arrow is positive 4. Same deal on the next one, first arrow in one step, so x squared. Then we're going to do those next two. They both end up in x terms, so I know that I can just do them there. Now, something interesting here, since we have negative x times negative 5 twice, becomes positive 5x, so this, when we add those two together, it's going to be 10x, and then plus 25. So that's the simplified version. We have one more step, not quite the simplified version. We want to combine like terms. So 1x squared plus 1x squared is 2x squared. And then we have plus 6x plus 29. So that will be a step in the systems we're going to see. Here is our first system in exercise 5. So I have y minus 1 equals x, and x squared plus y squared equals 25. So in the last lesson, we talked about how it's difficult to solve for y. This one's not too bad, but we actually have to get into, if we were going to solve for y, we'd have to take a square root because we have y squared, and then we need a plus or minus, and we actually end up with two functions. So solving circle equations, if you think about what a circle graph looks like, it's not a function. It's just not something that's easy to do. So we're not going to solve for y. Actually, in this equation, I already have it solved for x equals, so I can just take this information that x is y minus 1 and plug it into the other x. So I'm plugging in y minus 1 for x. So I get y minus 1 squared instead of x squared, and then the rest of the equation is like this. So the simplifying step is actually a little easier on this one, right? Because this second part is just a y squared. I write that twice. I'm going to do that one step for the binomials. So I have y squared, negative 1y is negative 2y. Negative 1 times negative 1 is positive 1. And in the next step, I'm going to combine like terms and also set this equation equal to 0 because I see that I'm going to have a quadratic with the y squared. So 1y squared plus 1y squared is 2y squared minus 2y. And then I'm going to combine my 1 and my negative 25 together to get negative 24. Then we move towards our factoring. So I can take out a 2 here and have y squared minus y minus 12. So that's 2 times y minus 4 times y plus 3. Just move the page down a little bit so we have a little more room. So 2 equals 0 is going to cross out, and then we have y equals 4 and y equals negative 3. So by getting the y values, remember in a system we've only answered part of the question, which is what is x and y. So up here I'm going to write my two answers that y is 4 and y is negative 3. I'm going to choose to plug it in the linear equation, so I'm going to use this one. So this says y minus 1, so 4 minus 1 equals x, so x is 3 in this case. And this one, negative 3 minus 1 equals x, so x is negative 4. Now in a lot of our systems, we solve for x first. Here we solve for y first. So just be careful that when you write your ordered pairs, you still put the x first. If you want to think about it like when we talk about parts to our question, y is always the first part of the question, and then x is the second part of the question, and it does matter in which order we answer those questions. So we have 3, 4, and -4, -3 for our answers. Now this one we're also going to do graphically. So I'm going to take those equations. I'm just going to rewrite them down here so we can see them. So my first equation is y minus 1 equals x. And to make this easier to solve, I'm just going to move the 1 over. So you could graph this on your calculator. You can also use mx plus b pretty easily here. And then my second equation is x squared plus y squared equals 25. So we'll start with a line. So we have a y-intercept of 1 and a slope of 1. And once again, I'm going to do the best I can graphing with the tablet. It's not going to be perfect, but here is our line. Our circle, we have a center of 0, 0. And a radius is the square root of 25, which is 5. So I'm going to have my center right here, and I'm going to go out 5 in each direction. Now, you'll see solving systems with circles, if you didn't already know the answers from algebraically, kind of depends on your graphing accuracy, and that's why we kind of say that algebraic is kind of better for circles. I know I have one answer at 3, 4. And we can see that our circle would go through that point. Okay, if we checked it, that point is on our circle. If we plugged in 3 and 4, 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. And then the other one over here, I don't even know how accurately I graphed my line, but that one's -4, -3, which is right here. I think I'm a little off as I went further on my line, but that point looks pretty accurate. So I draw in my circle. So we're still going to write equations on each one. Ideally, we write our original line equation, which is y minus 1 equals x. And then I'm going to circle those points. You can label them on the graph. That's totally fine. Ultimately, you want to write them off the graph to make sure you show that you understand what your answer is. So from the graph, I also got the answers 3, 4, and -4, -3. So we're going to do some more practice on the next page, but that's basically the process.